Hello YouTube, this is Jay Coder back with another stream, and today we're going to be going over a code lab that's about the view model in Android development. And view model is a pretty key concept in your learning of Android development, so I encourage you all to stay tuned so that you guys can be able to have all the knowledge that you need on this subject, because this is going to be a code lab that's going to thoroughly go over this concept of view model. And so if you have not subscribed to the channel, please go ahead and subscribe, and also like this video and comment on this video if you have any questions or comments or anything. And let's get started. I'm gonna go ahead and also post the link here in the chat, and so that anyone following along can be able to follow along with us here. So I'm gonna go ahead and post that here in the chat, and also I'm gonna alright, so I posted that in the chat for anyone to follow along, and I'm gonna go ahead and mute the music here. And so let's go ahead and get started with the code lab. Store data in view model. Before you begin, you have learned in the previous code labs the lifecycle of activities and fragments and the related lifecycle issues with configuration changes to save the app data. Saving the instance state is one option, but it comes with its own limitations. In this code lab, you learn about a robust way to design your app and preserve app data during configuration changes by taking advantage of Android Jetpack libraries. Android Jetpack libraries are a collection of libraries to make it easier for you to develop great Android apps. These libraries help you follow best practices, free you from writing boilerplate code, and simplify complex tasks so you can focus on the code you care about, like the app logic. Android architecture components are a part of Android Jetpack libraries to help you design apps with good architecture. Architecture components provides guidance on app architecture and is the recommended practice. App architecture is a set of design rules, much like the blueprint of a house. Your architecture provides the structure of your app. A good app architecture can make your code robust, flexible, scalable, and maintainable for years to come. In this code lab, you learn how to use Viewmodel, one of the architecture components to store your app data. The stored data is not lost if the framework destroys and recreates the activities and fragments during a configuration change or other events. Prerequisites: how to download source code from GitHub, open it in Android Studio, how to create and run a basic Android app in Kotlin using activities and fragments, knowledge about material text field and common UI widgets such as text view and button, how to use view binding in the app, basics of activity and fragment lifecycle, how to add logging information to an app, and read logs using Logcat in Android Studio. What you'll learn: introduction to the basics of Android app architecture, how to use the view model class in your app, how to retain UI data through device configuration changes using a view model, backing properties in Kotlin, how to use material alert dialog from the material design components library, and an unscramble game app where the user can guess the scrambled words, and computer with Android Studio installed, and the starter code of the unscramble app. So I'm going to go ahead. We need starter code for this particular lab. So I'm going to go ahead and post this in the chat as well for everyone to be able to download the starter code. I already downloaded it, so it's going to be ready here in my Android Studio. But for those of you tuning in, go ahead and download it from the GitHub here. And so now let's go ahead and continue. 2. Starter app overview. Game overview. The Unscramble app is a single player word scramble game. And alright, let me also see. Okay. Alright. And the Unscramble app is a single player and word scrambler game. The app displays one scrambled word at a time, and the player has to guess the word using all the letters from the scrambled word. The player scores points if the word is correct. Otherwise, the player can try any number of times. The app also has an option to skip the current word in the text in the left top corner. The app displays the word count, which is the number of words displayed in this current game. There are 10 words per game. Download the starter code, which I already posted the starter code link. This code lab provides starter code for you to extend with features taught in this code lab. Starter code may contain code that is both familiar and unfamiliar to you from previous code labs. You will learn about unfamiliar code in later code labs. If you use the starter code from GitHub, note the folder name is Android Basics Kotlin Unscramble App Starter. Select the folder when you open the project in Android Studio. Navigate to the provided GitHub repository page for the project. Verify that the branch name matches the branch name specified in the code lab. For example, in the following screenshot, the branch name is main. On the GitHub page for the project, click the code button, which brings up a pop-up. In the pop-up, click the download zip and zip button to save the project, and then locate the file on your computer in the downloads, and this creates a new folder. And of course, open it in Android Studio and go ahead and play it. Problems with the starter code. As you played the game, you may have observed the following bugs. So basically, this is what the game looks like right here. And so that's from the starter code. And so it says, on clicking the submit button, the app does not check the player's word. The player always scores points. So the player always scores points, even though, let me see, even though it's wrong. So obviously that's wrong. So I submit it. Boom. I still got points for the wrong one. There is no way to end the game. The app lets you play beyond 10 words. The game screen shows a scrambled word player's score and word count. Change the screen orientation by rotating the device or emulator. Notice that the current word, score, and word count are lost and the game restarts from the beginning. So when you rotate the screen, let me see. Does it respond to the root? Okay. Let me see. Skip. So we changed orientation. Okay. Alright, there we go. So when we changed the orientation, everything got reset back to 0. And maybe this is also a bug where this doesn't scramble because this word is not scrambled. But anyway, so what it's saying when you change to the landscape mode, it deletes all the data, or it loses all the data, and so that's where a view model comes in, so that the data can be preserved between screen orientations. Main issue in the app: the starter app doesn't save the restore the app state and data during configuration changes, such as when the device orientation changes. You could resolve this issue using onSave instance state callback. However, using the onSave instance state method requires you to write extra code to save the state in a bundle and to implement logic to retrieve that state. Also, the amount of data that can be stored is minimal. You can solve this issue using the Android architecture components that you learn about in this pathway. Starter code walkthrough. The starter code you downloaded has the game screen layout pre-designed for you. In this pathway, you will focus on implementing the game logic. You will use architecture components to implement the recommended app architecture and resolve the above mentioned issues. Here is a brief walkthrough of some of the files to get you started. So, game fragment.xml open, res layout, game fragment.xml and design, view. This contains the layout of the only screen in your app that is in the game screen. This layout contains the text field for the player's word, along with text views to display score and word count. It also has instructions and buttons submit and skip to play the game. Main activity.xml defines the main activity layout with a single game fragment. Res values folder. You are familiar with the resource files in this folder. Colors.xml contains the theme colors used in the app. Strings.xml contains all the strings your app needs. Themes and styles folders contain the UI customization done for your app. Main.activity.kt contains the default template generated code to set the activity content view as mainActivity.xml. List of words.kt. This file contains a list of words used in the game, as well as constants for the maximum number of words per game, and the number of points the player scores for every correct word. Warning: it is not a recommended practice to hard code strings in the code. Strings should be in strings.xml for easier localization. To keep things simple and to focus on architecture components, strings are hard coded in this app. Game fragment.kt. This is the only fragment in your app where most of the game's actions take place. Variables are defined before the current scrambled word, and current variables are defined for the current scrambled word count, so current word count and the score. Binding object instance with access to the game fragment views called binding is defined. OnCreateView function inflates the game fragment layout XML using the binding object. OnViewCreated function sets up the button click listeners and updates the UI. OnSubmitWord in the click listener for the submit button. This function displays the next scrambled word, clears the text field, and increases the store and word count without validating player's word. OnSkipWord is the click listener for the skip button. This function updates the UI similar to on submit word, except the score. Get next scrambled word is a helper function that picks a random word from the list of words and shuffles the letters in it. Restart game, and exit game. Functions are used to restart and end the game respectfully. You will use these functions later. Set error text field clears the text field content and resets the error status. Update next word on screen function displays the new scrambled word. And so, just so you guys know, what they're talking about is this project here in Android Studio. They're talking about the different code components inside the game. So they have like the game fragment here, and this is all of the game code here, which really isn't that much code for this game. And they have the list of words here. So all of these are the list of words that we are using in this collab. So about 200 words. And so each game session, they said they wanted to be 10. And then so the resources layout, got the game fragment layout here, which is the main screen that we are using. The fragment connected to the activity here. And so, yeah. 3. Learn about app architecture. I'll go ahead and close this guy for now. Architecture provides you with guidelines to help you allocate responsibilities in your app between the classes. A well-designed app architecture helps you scale your app and extend it with additional features in the future. It also makes team collaboration easier. The most common architectural principles are separation of concerns and driving UI from a model. Separation of concerns. The separation of concerns design principle states that the app should be divided into classes, which will separate responsibilities. Drive UI from a model. Another important principle is that you should give your UI from a model, preferably a persistent model. Models are components that are responsible for handling the data for an app. They're independent from the views and app components in your app, so they're unaffected by the app's lifecycle and associated concerns. The main classes or components in Android architecture are UI controller, activity fragment, view model, live data, and room. These components take care of some of the complexity of lifecycle and help you avoid lifecycle related issues. You learn about live data and room in later code labs. This diagram shows a basic portion of the architecture. UI controller display the data and capture user events, which is the activity fragment job, and holds all the data needed for the UI and prepares it for display, which is the job of the view model. UI controller activity fragment. Activities and fragments are UI controllers. UI controllers control the UI by drawing views on the screen, capturing user events, and anything else related to the UI that the user interacts with. Data in the app or any decision making logic about that data should not be in the UI controller classes. The Android system can destroy UI controllers at any time based on certain user interactions because of system conditions like low memory. Because these events aren't under your control, you shouldn't store any app data or state in UI controllers. Instead, the decision making logic about the data should be added in your view model. For example, in your unscramble app, the scrambled word score and word account are displayed in a fragment UI controller. The decision making code such as figuring out the next scrambled word and calculation of score and word count should be in your view model. View model. The view model is a model of the app that is displayed in the views. Models are components that are responsible for handling data for an app. They allow your app to follow the architecture principle driving the UI from the model. The the view model stores the app related data that isn't destroyed when activity or fragment is destroyed and recreated by the Android framework. View model objects are automatically retained. They are destroyed like the activity or a fragment instance during configuration changes so that data they hold is immediately available to the next activity or fragment instance. To implement ViewModel in your app, extend the ViewModel class, which is from the architecture components library, and store app data within that class. To summarize, fragment activity responsibilities, ViewModel responsibilities. So the fragment activity responsibilities. Activities and fragments are responsible for drawing views and data to the screen and responding to the user events. And the view model is responsible for holding and processing all the data needed from the UI. It should never access your view hierarchy like view binding objects or hold a reference to the activity or the fragment. So, so basically, a good architecture is called a model view model, which is MVVM. You might hear that in different places for Android development. So that means we're using what we call a view model, which the view model is responsible for storing. It's like it was saying before. It's responsible for holding and processing all the data. All the data needed for the UI, and so it's separated from the UI in that way, where It should not ever be able to access the view hierarchy or hold a reference to anything in the UI, because the UI is responsible for updating the screen. Anything on the screen, they just get the data from the view model, and then once they have the data, they will update it from the screen. But they don't worry about, updating the data. The view model worries about updating the data. In this test, you add a view model to your app to store your app data. Scrambled word and count and score. Your app will be architected in the following way. Main activity contains game fragment, and the game fragment will access information about the game from the game view model. In the Android window of your Android Studio under the Gradle scripts folder, open the file build.gradle module unscramble app, and to use the view model in your app, verify that you have the viewmodel library dependency inside the dependencies block. This step is already done for you. Depending on the latest version of the library version number and the generated code might be different. So in order to use the view model, make sure you're implementing this uh, implementation Android X lifecycle dash view model inside your Android Gradle file. So to check this out in our app, we can go to our Android Studio. Then inside our Android Studio, we can go to the Gradle scripts, and inside the Gradle scripts, we can go to the project here, and then inside the project here, or I'm sorry, not the project Gradle, but the app module Gradle. And then so we are looking for the view model. So we have the view model right here. So make sure you use that, or you have that implemented in order to use the view model class. So now create a new Kotlin class file called game view model in the Android window. Right click on the UI game folder and select new Kotlin class. So in the UI game folder, let's see, inside our Android Studio, inside the UI game folder, I'm going to right click and say new Kotlin class. And this new Kotlin class is going to be game view model. And then we're going to press enter. And then looks like this game view model is going to inherit from the view model class, which is built in to Android. So we're gonna go ahead and actually so let's go back to our Android Studio. Then we're gonna add the view model here, and it's gonna actually be colon, and then here we gonna import that. Alright, and looks like it's good to go there. Attach the view model to the fragment. To associate a view model to a UI controller activity fragment, create a reference object to the view model inside the UI controller. Inside this step, you create an object instance of game view model inside the corresponding UI controller, which is game fragment. At the top of the game fragment class, add a property of type game view model. Initialize the game view model using by Viewmodel's Kotlin property delegate. You will learn more about it in the next section. So, 3. If prompted by Android Studio, import this dependency. And so they want us to initialize the game view model inside our Kotlin code. At the top of the game fragment class, add a property. So we add this property at the top of our game fragment class. Okay. Inside our Android Studio. Inside our game fragment class, we're going to make this. Then we're going to import that. Alright, so we're going to be using our view model from our game view model, which we haven't added any code to it yet, but we're setting it up. Alright. Then back to our Android Studio, back to our lesson. If prompted by Android Studio, oh yeah, we did that. And Kotlin property delegate. In Kotlin, each mutable var property has default getter and setter functions automatically generated for it. The setter and getter functions are called when you assign a value or read the value of the property. For a read-only property val, it differs slightly from a mutable property. Only the getter function is generated by default. The getter function is called when you read the value of a read-only property. Property delegation in Kotlin helps you to hand off the getter-setter responsibility to a different class. This class, called delegate class, provides getter and setter functions of the property and handles its changes. A delegate property is defined using the by clause and a delegate class instance. Syntax for property delegation. In your app, if you initialize the view model using default game view model constructor like below, then the app will lose the state of the view model reference when the device goes through a configuration change. For example, if you rotate the device, then the activity is destroyed and created again, and you'll have a new view model instance with the initial state again. Instead, use the property delegate approach and delegate the responsibility of the view model object to separate to a separate class called view models. That means when you access the view model object, it is handled internally by the delegate class. View models, the delegate class creates the view model objects for you on the first access, and it retains its value through configuration changes and returns the value when requested. Move data to the view model. Separating your your app's UI data from the UI controller, your activity slash fragment classes lets you better follow the single responsibility principle we discussed above. Your activities and fragments are responsible for drawing views and data to the screen, while your view model is responsible for holding and processing all the data needed for the UI. In this task, you move the data variables from game fragment to game view model class. 1. Move the variables score, current word count, current scrambled word to game view model class. Notice that the errors about unresolved reference. So they want us to move these variables to the view model class. And then once we do that, once we do that, we have unresolved reference. So we move these three variables to the game view model, and so now we have to see how we properly access these variables from the view model. Notice that the error is unresolved. This is because the properties are private to the view model and are not accessible by your UI controller. You'll fix these errors next. To resolve this issue, you can't make the visibility modifiers of the properties public. The data should not be editable by other classes. This is risky because an outside class could change the data in unexpected ways that don't follow the game rules specified in the view model. For example, an outside class should change the score to a negative could change the score to a negative value. Inside the view model, the data should be editable, so they should be private and var. From outside the view model, data should be readable, not editable. So the data should be exposed as public and val. To achieve this behavior, Kotlin has a feature called a backing property. Backing property. A backing property allows you to return something from a getter other than the exact object. You have already learned that for every property, the Kotlin framework generates getters and setters. For getter and setter methods, you can override one or both of these methods and provide your own custom behavior to implement a backing property. You will override the getter method to return a read-only version of your data. Example of backing property. So we have the private var underscore count and the val count here equals the underscore count. Consider an example. In your app, you want the app data to be private to the view model. Inside the view model class, the property count underscore count is private and mutable. Hence, it only is accessible and editable within the view model class. The convention is to prefix the private property with an underscore. Outside the view model class, the default visibility modifier in Kotlin is public, so count is public and accessible from other classes like UI controllers. Since only the get method is being overridden, this property is immutable and read-only. When an outside class accesses this property, it returns the value of underscore count and its value can't be modified. This protects the app data inside the view model from unwanted, unsafe changes by external classes, but it allows external classes to safely access its value. Add backing property to current scrambled word. In game view model, change the current scrambled word declaration to add a backing property. Now, underscore current scrambled word is accessible and editable only within the game view model. The UI controller game fragment can read its value using the read only property current scramble word. Private var underscore current scramble word equals test. Val current scramble word string get equals current scrambled word. In game fragment, update the method in game fragment, update the method update next word on screen to use the read only view model property current scrambled word. Private fun update next word on screen binding.text view unscrambled word.text equals view model dot current scrambled word. In game fragment, delete the code inside the methods on submit word and on skip word, and you will implement these methods later. You should be able to compile the code now without errors. Never expose mutable data fields from your view model. Make sure the data can't be modified from another class. Mutable data inside the view model should always be private. Alright, so inside the game view model, change the current scrambled word declaration to add a backing property. So okay, inside our view model, we're gonna change it to this. So let's see. Inside our Android Studio, we're going to go to our game view model. Inside our game view model, it wants us to do it like this. So instead of just simply declaring the private var current scrambled word test, we're going to indeed declare it like this, so that we have a variable that can be accessed from outside in a read-only format outside our class, and then a variable that can be editable inside our class. So we have the best of both worlds. So when we share the variable with outside classes, those outside classes cannot modify the value. They can only read the value, which a UI a UI component like activity or fragment should not be able to directly change a value inside the view model. The view model is the person or is the class that is responsible for changing its own values. Now, yeah. So basically that's what this means. And so we have to do I believe we have to do that for these two other variables. So for instance, like this one is going to be like this. Inside our view model. That's our count. Or actually, we don't have one called count. We have one called score. Gonna go ahead and well, just for example, I could leave that there. Let me see. Um, mm, I'll just it's gonna be just for reference. This is actually score. Alrighty. So that's what's required to declare those inside our view model. The life cycle of a view model. The framework keeps the view model alive as long as the scope of the activity or fragment is alive. A view model is not destroyed if its owner is destroyed by for a configuration change, such as a screen rotation. The new instance of the owner reconnects to the existing view model instance as illustrated by the following diagram. Understand view model lifecycle. Add logging in the view model and game fragment to help you better understand the lifecycle of the view model. In game viewmodel.kt, add an init block with a log statement. So inside the game viewmodel.kt, we're going to add this to the init. And so inside the viewmodel.kt, going to go ahead and add this init. Perhaps we can add the init here, and then we're going to log the view model has been created. And then Kotlin provides the initializer block, also known as the init block, as a place for initial setup code needed during the initialization of an object instance. Initializer blocks are prefixed with the init keyword followed by the curly braces. This block of code is run when the object instance is first created and initialized. In the game view model class, override the onCleared method. The view model is destroyed when the associated fragment is detached or when the activity is finished. Right before the view model is destroyed, the onCleared callback is called. Add a log statement inside onCleared to track the game view model lifecycle. So, okay. So, they said add a statement inside onCleared. So, we're going to override a function called onCleared to log. Okay. Right before it's destroyed, onCleared is called. So, we need to know when the view model is destroyed. So let's go back to our Android Studio. And then inside our Android Studio, inside our game view model class, we're going to add this method, which is a built-in method that we're overriding called onCleared. And when the onCleared is called, then basically the game view model is destroyed. So for in-game fragment inside on create view, after you get a reference to the binding object, add a log statement to log the creation of the fragment. The on create view callback will be triggered when the fragment is created for the first time, and also every time it is recreated for any events like configuration changes. So we have this the function on create view, and so all right. So let's see. So it wants us to, inside the game fragment, inside the onCreate view, after you get a reference to the binding object, add a log statement. So inside our onCreate, we're going to add this log statement that the game fragment was created. So inside our Android Studio, we go to our game fragments, or yeah, this is our game fragment. And then inside our game fragment, they want us to, first of all, we can delete these. Actually, they want us to put it inside the onCreate after the binding is called. We're going to log the game fragment created. Alrighty. In game fragment, override the on detach callback method, which will be called when the corresponding activity and fragment are destroyed. So we're going to override this built-in method for the fragment that is called onDetached, so that we can see. I'm gonna put it after the onCreate view. So it's onDetached, and then it will call this when the fragment is destroyed. Android Studio. In Android Studio, run the app, open the logcat window, and filter on game fragment. Notice that the game fragment and the game view model are created. There is another thing. I don't remember them telling us to deal with these variables yet, which these variables we have to access. Well, actually, yeah. But, okay. Right now, I'm going to go ahead and call it a day for this stream right now. And so I'm going to go ahead and return with the next stream to continue this. And we're going to continue with a part 2. And so I appreciate you all watching this stream so far. And stay tuned for the next part of this code lab. So don't miss that. Go ahead and subscribe to this channel, comment on this video, and also like. And As always, I want to encourage you guys to stay coding. All right. Have a wonderful day. Bye.